This might be the stupidest video you've ever watched, but I promise you're either going to be entertained or learn a couple things along the way. My name is Wes. I'm a full stack JavaScript developer.
Little bits of JavaScript, which is a kind of computer code.
And this is my family's old Roomba. It's not very good anymore. So like any good developer, I thought, can I put JavaScript on it?
And I heard a boy who was about 10 years old, and he was walking around with JavaScript for Dummies, berating one of the other kids for not being able to code in Java.
Turns out the answer is yes. Now, I've worked with JavaScript and hardware a couple times in the past. Let's try flip. Ready? Oh, that's fun. And land. That let thousands of people send me random images and text all throughout the day. I burned through so much paper doing this. But this is the first time I actually used an ESP32 microcontroller and JavaScript together. I learned a ton. Had a lot of fun doing it. And I highly recommend this to anybody. The following is a detail of me learning, controlling, building, coding, everything on controlling this thing with JavaScript. So to start things off, this is a Roomba 730. I have a 720. They're all about the same, and you can find them on Marketplace for 20, 30 bucks because they're not that good of a vacuum. But if you take something sharp and you pop the top off of it, there is a little 7-pin DIN connector that allows you to communicate with the Roomba. So iRobot is a really cool company, and they actually provide you with a whole documentation on how to communicate with the Roomba. This little 7-port, there are kind of a couple important pins on here, right? We have the RX and TX. Those are the receive and transmit serial port connections. And then there's also a ground connection, a baud rate change, which is I'm not going to get into it, but it's basically the rate at which you communicate with it. And then some additional pins for grabbing power off of the Roomba. So this vacuum doesn't have Wi-Fi in it, doesn't have USB. All it has is this little interface for sending and receiving data over serial, and computers don't have serial ports anymore. If you remember back, the old printers had those really wide ones. Those are parallel ports. Serial ports came before that. So I have this, which is a USB to serial, and on it there are a number of pins that have transmit, receive, and ground. Those are the three important ones. And then there's also 2 pins for 5 volts and 3.3 volts, which are common for powering electronics. So we take a couple jumper wires, and I've hooked up the green to the ground and purple and blue to transmit and receive. And then you go to the port on the Roomba and you hook up the green to ground and then the opposite. So transmit goes to receive and receive goes to transmit. Now we've essentially made a USB port on the Roomba, and we go ahead and connect that to our computer. Now to communicate with the actual serial port, there's a package in Node called serial port, and that will allow you to list all of the serial ports that are connected to your computer. And if you plug it in, you'll see there's all of my headphones, there's some Bluetooth stuff, and then this is the one that I'm looking for right here. You can verify it by plugging and unplugging it again. Now, when you go ahead and connect to the serial port, we need to start sending it some data. And Roomba provides you with all of the data that you can send it, right? So first you send opcodes, and then there's additionally some bytes that you can send along with it. Kind of like this is the function, which is the opcode of start, and then there are sometimes arguments of things that you want to send along with it, right? And of course, there's start and stop and reset and whatnot, but there's also the ability to start cleans, drive the frickin' thing, have full control over the motors, access the LEDs, grab all the sensor data from it. It's pretty amazing that they just give you the directions to control the whole thing. So we go ahead and connect to it via here, and then we run a start command. We put it into safe mode, which will allow us to start sending commands to it. There's also a full mode, which will ignore absolutely everything. Well, the thing will fall off the desk if it needs to. And then we go ahead and start writing commands. So command 137 is the drive command, and it expects 4 bytes. We'll go ahead and run that, and it should send the drive command. There we go. It's driving it right off my desk at a very slow speed definitely we're going to crank that sucker up as well. So that was really exciting to me that via 50 lines of code I was able to start communicating with this thing. So the next step I thought, like, let's make a actual UI for it. So I brought it into the browser, and in Chrome and in Chrome-like browsers, there is a navigator.serial.request port API, and this allows you to actually write serial data directly from the browser without having a node backend. So I built this little UI here. So we'll go ahead and connect to it. I have an initialize method here. There's our USB serial port 002. Go ahead and connect. And you hear that doo-doo. What I did there is I started it, I put it into full mode, and then I went ahead and run a beep command, which sends a MIDI song to the Roomba itself. Of course, we had to hook it up to some buttons. Oh, I did not. Some buttons. Oh. I forgot. I put it at absolute fast speed in this demo. So obviously it just drove off the desk and it's totally gone. But all right, I've collected myself. I was not expecting that. But what we have here is some buttons. Those are hooked up to the various methods that I've written in here. And there is one called drive PWM. And what this does is it sends the command of drive, which is 146. We have that in here. If we take a look, here we go. And it takes a number of additional bytes of how to power the right and left motors, which are the driving speed, as well as how fast to actually drive it. And then I just hooked those up to a button and I was able to control it. So that was amazing because I was able to control it straight from the browser without having to need a process in between. And then the third thing I did was I tried to hook it up to Bluetooth. So I moved over to one of these, which is called an ESP32. And this is an amazing little device. What this is, it's about $5. I'll put links below on it. You can get them on Amazon or from AliExpress or whatever. And this is a microcontroller that has both Bluetooth and Wi-Fi in it, and it also has those header pins that we're used to. So my idea was to connect this here and then be able to send commands from the browser over Bluetooth. That ended up working because it wasn't Bluetooth LE. This does support Bluetooth LE, but I ended up scrapping it because I thought, I want this thing to work on the iPhone anyways, and this serial port API is not available on the iPhone, so I need to sort of go back to the drawing board and look at different approaches. So where I'm at is I want to be able to take this ESP32, plug it into the Roomba, and to be able to open up a browser and control the thing directly. I want it to be entirely on the ESP32, so I don't have to have a computer or server running somewhere. Now, the solution that I landed on, everyone's saying, oh, clickbait, you're not actually running JavaScript on the ESP32. I'm running it on the ESP32. I did have to write a little bit of C++ to sort of hot potato the signals from the browser over a WebSocket and then out the TX, RX ports on the ESP32. There are a bunch of ways right now that are trying to put JavaScript on microcontrollers. There's TC53, which they're trying to standardize the APIs for communicating with microcontrollers in JavaScript. There are things like Quick.js, which is a C-based JavaScript runtime. So this is small enough and fast enough that you'll be able to actually put it on a microcontroller. There is Esprino, which has their own runtime. There's Moddable, Vim out there. You can run it on a Raspberry Pi, which is more like a Linux computer with I/O on it, but I wanted to run it on straight away on a microprocessor. So if we take a look at the C++, by the way, I've never written C++ in my life. I forked this thing and I was able to sort of figure it out. I used a lot of cursor, typed in what I want, and it sort of modified it, got me through a lot of issues that I wouldn't be able to get through otherwise. And what it does is it starts up a WebSocket server that when some WebSocket data comes in, it comes in as JSON. I deserialize the JSON and then simply send that command out the serial port, transmit, receive, or it's the transmit port, and that goes directly into the Roomba. Then I also have a little bit of setup code. It runs those start commands. It writes a couple songs to the Roomba's memory so we can use it as a honk honk a little bit later. And then it also fires up a web server that we can use for serving up the React.js application that does live on the microprocessor itself. Now, this code here is actually Arduino code that will run on the ESP32 microcontroller. And instead of using the Arduino editor, I actually use this thing called Platform IO, which is a VS Code plugin, and it will connect directly to the USB port. So you'll see that this thing is plugged in via USB. I've selected it right here. And then you can go ahead and compile your C++ into a bin file, and that's the custom firmware that's going to be running on the ESP32. So go ahead and built it, and then when it's done, you can click on the upload button. That's going to connect to the ESP32 and upload the custom firmware. Once that's done, the ESP32 will reboot itself and run that custom firmware, and you can see what's happening by clicking on the serial monitor. Now, this is kind of like a terminal for seeing any console logs that is running on the microprocessor itself, and any logs they have in your code, as well as any serial data that is sent from the Roomba to the microcontroller over the transmit receive ports. You're going to see it log out on here. So I'm just going to click on the reboot button on the ESP32. Watch how fast this is. Boom. It immediately fires itself up, and it will wait for a Wi-Fi connection. And then I added this, the MDNS. This will allow me to visit it directly via roomba-esp32.local instead of visiting the IP address directly. And then we start it up. We run the start command. And now we have a web server that's running at our Roomba ESP32-local. If we go ahead and visit that in the browser here, it loads up the React application. You already see that we are receiving data back and forth and being able to send commands. So there we go. We can honk it. We can turn the LEDs on and off. And of course, we can start start to drive this thing, which on a desktop, it's not that interesting because you're connected to it. But now if I unplug it and plug it into a battery, now the thing boots up. We're totally wireless, and I should be able to visit. I'm using my phone to record. I can't use my phone, but imagine you're able to open this up on your phone, and the WebSocket, there we go. It just reconnected itself, and I'm able to drive this thing precariously all around my actual desk. And it's just creating a WebSocket connection to the ESP30 microcontroller. Again, the React application is running off of a web server that's running on the microcontroller, and we have full control over it. We can turn on the side brushes. You can turn on the vacuum. You could turn on the main brushes underneath. The side brushes allow you to reverse the direction. This is actually kind of cool. So if you'll take a look at the documentation for the motors, the code for sending the motor over is 138, and it only takes 1 byte of your configuration to turn on. But there's 4 different potential options, right? There's 3 different motors, the side, there's the vacuum, and then there's the main brushes that run underneath it. And then there's also the ability to run the brushes in reverse. So there's 5 different possible options that need to be sent via 1 byte. And the way that we actually do that is you simply just send ones and zeros. So if you want the side brush to turn on, you send a 1 in that location. And if you want the vacuum to turn on, you send a 1 in that location. So I wrote a little bit of code that converted these checkboxes to literally binary and then sent that over the wire to this. And it's pretty nifty. I understand binary, but that's probably the first time I've actually had to write it. And just doing these things just gives you that big aha moment. There's also sensor data that is being pulled in. It looks like it's not being pulled in right now. Probably something wrong with it. But the sensors on here, there's all kinds of them, right? There's 2 sensors that will use infrared to figure out if something is in front of it. There's these bump sensors on either side to figure out if it's hit something. There's sensors to figure out if all 3 of the wheels are lifted or not. There's sensors to figure out what the battery is, the amperage draw of the motors, because maybe it's sucking up something that's too high. Absolutely full control over this thing. Oh, hold on. I just figured out why my sensor data is not working, it's because my receive wire has been unplugged. So I'm going to take the receive wire, plug it back in here. Let's see if we can now request the sensors. And boom, there we go. I'm getting all the sensor data coming in. I just had the wire unplugged. That's why it's not working. And you can see if I were to lift up one of these wheels and then request the sensors again, you see the left wheel has been lifted. Now, the React app itself, there's quite a bit to it, right? We have this whole controller here. This is a advanced commands, right? You can send just raw commands to it. You can see the console output. You can run these like start and stop, because one time I accidentally unplugged the controller while it was in full mode, and then I couldn't wake it up. It was just like almost like bricked. So I had to reconnect it, and I added some commands here that would sort of wake it back up via the bytes that it sent. So there's that. Obviously we have the honk and the LED. All of this UI was built entirely by Cursor, probably 99% of it. The only thing I had to do was debug a weird iOS issue with the touch events on this thing. And that took me maybe 20 minutes or so. And it ended up being a transition that was longer than the actual touch event, and it was getting a little bit funky. So all of that, plus all of the code to write the binary data for turning the vacuums on and off, that was entirely done via Cursor. I would just send it screenshots of the documentation PDF. It knew quite a bit about the Roomba open interface, and it did a really good job. And I don't know that I would be able to do all of this without Cursor. I could obviously build the UI. It would have taken me much longer, but the C++ stuff, as well as even just like this little drag and drop interface right here, that took me like maybe 6 minutes, versus that would have taken me a whole day to build this little joystick interface here. Now, getting the React app on the ESP32 itself, the app itself is like 1.9 megs. In order to make that small enough to fit on here so the web server can serve it up, we use this little script here. And first what it did is it converted the HTML to gzip format, which significantly decreased it. And then we used a tool called XXD, and that converts the gzip over to hex values. And that's what the ESP32 uses when somebody visits the web server. It will just take the raw hex bytes, send them out via Wi-Fi, and then we can access it via the server, which is pretty neat. So now I simply just need to plug it in. I can tell my kids to go to this URL as long as they're on the Wi-Fi, and they can run this thing and control it wherever it is that they want. This was a really cool project. There's still a lot more I would love to do with it. I would love to add a camera to it. Sam Meach-Ward is actually working on sort of a similar project right now, and he's thrown a camera on his. Imagine we could live stream this thing with a camera, and then I'll give you guys control over how it works. I would love to be able to power it from the Roomba's battery itself. The Roomba itself puts out 19 volts. The ESP32 runs on 3.3 volts or 5 volts. And I have buck converters, but I just didn't feel like messing with dropping the voltage down and building a whole circuit. This is fine. I'll tape it on there, and it will be good. This was a really fun project. A lot of hate. A lot of people saying this is stupid. I hate JavaScript. Why would you ever try to put JavaScript on a microcontroller? And
and I have sympathy for anybody who has to deal with JavaScript.
I understand. That's probably not the best approach. But learning something new, being able to get excited to do things, if you are at the very least feeling any but burnt out, I'm going to encourage you to pick up a stupid project where you can do things like this, because it is really fun. It really ignites your passion for coding, and you get to learn a lot of really fun things along the way, right? I learned a whole bunch about microcontrollers. I learned a lot about serial, about binary data, about communicating, WebSockets, C++ even. Really cool. So I highly encourage you to, if you see one of these suckers on the side of the road, you see it at a thrift store, they're all over the place, Facebook Marketplace, go grab it. Grab yourself a $5 board, get the code base here, and try to get this thing running. Hopefully you enjoyed that. Make sure you subscribe. Peace.